So my name is Nate. I work for a search company, Opensource Connections. This talk is about a bunch of work that we're super proud of, and we worked in collaboration with SimpleTire to do. And it's really all about all of the cool, crazy, wild things you can do with Painless in a search system. So yeah, let's jump in. So who we are, right? I just gave you a little bit about me. I'm a relevance engineer, kind of specializing in Elasticsearch. It's a pretty good search engine. If you've heard of it, I'm sure that's why you're here. Mark Pereira, he's the other principal person, principal architect at SimpleTire. Overall, great guy too. I'll have a shout out at the end. But if any of this stuff sounds interesting to anyone, they're actively recruiting a search architect. So if I didn't have some contractual stuff in the way, I would be right there. They're a fantastic place to work. And what SimpleTire does is they're really kind of a forward-looking digital first tire retailer. So it's a space that really has not had maybe as much digital investment as before. And so what these people are doing is bringing a lot of complex logistics calculations, new kind of ways of sourcing stuff, and driving down a bunch of prices. So if you're in the States and you need tires, I do not get any kickbacks from the tires you buy, but I recommend everyone goes there, and you save money. Like I saved like about $100 last time I bought off the other big tire people. So this isn't a pitch at them though. So they're just a great place to work. So I encourage anyone who thinks this talk is good to go out and look at it. I do want to take a quick second because this talk is really the product of an entire organization working for a very long time and a lot of smart people contributing to it. I'm just here kind of talking about the elastic icing on top of the cake. And this is just a few of the people that directly touch the code. Jitin Modi, a fantastic engineer. We could not have done it with his help. Kevin Klingenhofer, fantastic DevOps engineer, could not have done it with his help. Chris Vital, Chris Danielle, their VPs. So yeah, they helped guide this process and make sure everything. And Rich Zapp is the head VP of digital experience, and Kenny Pratt is the CTO of the company. So my OSC colleagues, Dan Worley, Max Irwin, and Becky Billingsley, you guys are great. You already know that, but could not have done it without them at all. So just want to kind of go in and remind everyone that this is all about what you can do with a great team behind you. So what did we actually do, right? So what we're talking in this, we're referring to it as merch score in this talk, and it's really about merchandising products with a lot of data, personalization behind it, and doing it all in real time, being served up by the Elastic engine. And what the goal of this is not just to maximize the bottom line. We're trying to kind of tailor a bunch of different ranking algorithms to different segments of our customer base, right? We did a ton of user research, literally a year and a half of user research before we ever really touched Elastic Code, trying to figure out who uses the site, who's looking for what, and we wanted to deliver that to them, right? We knew the segmentation of the audience, and so our job kind of as engineers was just to implement all of that. What the merchandised or the merch score really is when a product is scored based on different attributes, right? We want to give these like custom facets of our catalog to people. We need these things to be dynamic, right? Lots of this is driven by location or region and even seasonality, right? If you're in Michigan and it's going into December, you might want to have a look at snow tires more than you want to have a look at summer performance tires, right? Things like that. And what we really want to do is capture this idea of value, right? Whatever that value is, it's not just something as simple as price all the time. It means a lot of different things in these different rankers that we're going to talk about next. And then we're even going to take this a step further and tailor it to individuals, right? We've identified segments that prefer to have certain brands, higher end, lower end tires with longer durations, things like that. And we can actually deliver personalization signals too, based on what we know about viewing history on the site, based on vehicles you drive, all these things like that. So it's really a fantastic logistics and data science problem. And it was absolute ton of fun to work on. So the general types that I want you guys to kind of think about is like expert buyers, do-it-yourselfers, car enthusiasts, people who are nervous about their cars, and then people looking for deals, right? So those are just some ideas of what kind of phenotypes we get across the site. So this is the merch score. This is it's pronounced merch score, right? Just like merchandising. And I'm going to refer to this a lot. It's a noun, and what it means is this multi-component ranking function for search. And the goal here is we need this thing to be balanced, and we need it to be flexible, but it has to kind of be a sum of a variety of components. And ultimately what ends up is kind of that perfect ranking, right? And maximum success, really. It's not just all about money, but we want to be able to remix this at will, right? And so that is what we're really after, right? And so Elastic Painless was the perfect thing to pull off the shelf for this. So this is the original merch score recipe. Well, what it was, like I said, was a product of a lot of hard work by the user experience and product team, right? All we had to do was take their hard work and code it into Elastic, right? Coming up with this is obviously, in my opinion, a much harder deal, right? It's like doing machine learning without data cleaning, right? Data cleaning is the hard part. The machine learning with clean data is relatively straightforward. So this is what we wanted to do is take all of that excellent detail that we had and actually put it in. So there's a couple different components, right? The parts that users care about: price, ratings, reviews, things that the business cares about. Remember, this has to be this balanced blend of things: profit, sales, distance to the consumer. Can we incorporate real-time information about where you're actually searching from? And deliver a warehouse close by, right? If we're in a right position, maybe we can deliver you a more valuable tire or something like that we want to sell as the business. So a little bit of technical background. What we were doing originally to create this stuff, obviously it started in the land of spreadsheets and notebooks, and we migrated to a SQL job that was being run as a cron job every 6 hours, and we were including an index time. But the thing there was that data kind of gets stale pretty quick, right? So we wanted to kind of figure out a way to move it to Elasticsearch. Number one, Elasticsearch was a ton faster than what we were doing in MySQL, right? Anyone who uses Elasticsearch could tell you that. But also these other things, the batching was slowing us down. And then the data and the tooling, we weren't able to try out configs with the MySQL job as easily as we could with Elastic. And I'll show you some of the stuff we're able to do by flexibly passing in different parameters to those Elastic scripts. You really get the opportunity to test different rankers very quickly. And iterate and try a bunch of different things. So it's very, very nice to be in a painless environment. So just in case you've never heard of Painless, want to do a quick recap here of what Painless is. And there's three things that the Elastic Docs, this is lifted directly out of the Elastic Docs. And there are three things that it focuses on, right? Safety, performance, and simplicity, right? I'm adding this fourth bullet in, flexibility, because when I first came in, to the search world, everyone was like, "Oh, Painless is cool, but it can be hard to work with, right? It can be painful to work with." It was kind of a running thing that I heard time and time again. So when I picked up this project, I had a little bit of trepidation around it, but I think Painless is actually great, and it's insanely flexible. And I'm going to kind of show you how flexible it can be. So first pass here is kind of encoding some basic logic, right? If a product has an average rating above a certain threshold value, we're going to give it a 1, or if not, we'll give it that 0, right? So this is kind of a very simple if-else conditional, but it lets you go in and directly access doc values, right? So we've indexed those values about what the user rating was as of yesterday at midnight, and now we're able to kind of take it for a ride in terms of getting the scoring to reflect that. So it's based on Groovy, Turing complete language. You can do a lot of the regular stuff you do with Java, import math libs, use math functions, stuff like that. So lots of developers feel very at home in Painless, which is a nice perk if you have another language. Painless just kind of does it. This next slide is Painless getting a little more flexible, right? So like I said, it's a Turing complete language. You can define variables. You can do all sorts of lengthy sums, various checks, do a bunch of math syntax, and really do whatever kind of arithmetic you want to do on your score, right? So Painless will let you do it. You just can't return negative values, right? This is a Lucene search engine at the end of the day, and if you have a bunch of negative values, that's not good, right? And also Painless gets a little, can get very, very crazy. So what we ended up doing actually for some of this is calculating great circle distance inside of Painless scripts, right? Is this the most performant solution for calculating distance? No. But if you have a relatively small e-commerce index, right, we're talking 50, 100, 150,000 documents, this still holds up and it's still very, very fast in terms of the overall load time on the page, right? So far that we didn't even care about it. And what we were able to do with this is you're able to iterate through nested fields. That's why we kind of went down to this. But what you can do is you can iterate through nested fields. You can look for the best tire in those nested fields. We're using them here to store warehouses. But what we can do is kind of do this product math and look for all of these margins on the fly, right? Remember, the whole point of this was being dynamic, right? Prices have changed, user distances are obviously changing with each search, and Painless allows us to be super flexible. So we kind of joke now that it's not just flexible, it's actually double jointed. So, and then this is just kind of a nice mental recap, right? You always have to check fields exist, right? Painless might be super flexible for you, but it's actually kind of taking a lot of the guardrails off that traditional Elastic queries would already kind of save you from yourself, if you will. And so if you don't check or you end up returning negative values, you're going to have a bad time, right? You'll get some nice fun errors that you just want to make sure you catch those in testing before you go to prod. And of course, we did that. So this is really where the blend comes in though, right? Is we're not just going to use one of these off the shelf, right? You think about that first one, if else statement. We're going to actually start to blend these together, right? And you're able to re-weight, not just blend different components together, but you can also blend different weights together, right? So this is the original merch score recipe, just as an example on the top. And you can imagine quickly kind of changing the params or passing into each of those. And now we get kind of what we call a balanced merch score. So you can see the opportunity here to configure, dial in different variants is really easy and right at your fingertips. This next big piece is kind of using these params, just like we were with the user's location and the first round of examples, is to carry in these weights too, right? So this is just another little couple of characters at the end of your Painless script and you get a weighted version of it. The third big step to do this is you want to use compiled scripts, right? If you're doing anything with Painless, highly, highly recommend compiling them. This is essentially like indexing them. You just put them at the cluster level when you upload other things to your index, and they'll sit there and live happily ever after, and then you can reference them by name. So not only does this make your code much more readable, it also makes it much more performant at the same time. So it's really nice from that standpoint. And then the fourth step is really we're gonna wrap all of this in everyone's favorite combined query in Elastic, the Boolean query. We're using the should clause here. We want these to kind of all stack together and be additive. And this is very, very nice wrapper, but not necessarily part of this. It's just how we're combining scores in Elastic. So this is kind of the architecture diagram of how this stuff stuck together, right? So user, customer, comes to SimpleTire all the way on the left. Hopefully they're not driving while they're at SimpleTire, but they're accessing the website, thinking about their car. We hit the search API, and then what the search API actually does is it look back and kind of call out to this baseline merch score. The merch score itself is actually stored in a SQL DB, right? Remember, it's included at index time and it's ready to go. And only then do we reach out and hit Elastic Cloud. We used Elastic Cloud for this and absolutely loved it. Highly recommend if you're looking for a nice cloud hosted solution. And it's really a treat to work with. But what this lets you do is you can start storing those things in that DB. Not only do you get a record of it, you also get the ability to kind of let other maybe non-developers interact with that code, right? If you have a business intelligence team that wants to interact with the weights column via some tooling they have to interact with SQL tables, that's perfect, right? So putting it into something like SQL really lets the business analysts go back and kind of take control of it without actually having to know any Elastic DSL, right? That's a big win for the business too. So when we just rolled out the baseline merch score, just going from kind of what we were doing with the stale data, the ranker, and incorporated at index time every 6 hours, we saw a 3% lift in our conversion rate. So I'm going to use a lot of truck memes and truck images through the rest of this to go with the lifted truck metaphor for this. But 3% increase in your e-commerce shop is nothing to sneeze at, right? Easily paid for the Elastic Cloud bill for that month and the next couple of months. Now, the next step here is we talk about all that flexibility. We're not going to just stop at one merch score. We have the baseline merch score. We know it works. It's doing exactly what we want. Now what we want to do is we want to expand it, multiply it, kind of let it replicate into what we're going to call these curation merch scores. You could think of these as specialized variants targeting one of those niche personas that we're after, right? And that's what we want. So this is what it ends up looking like on the site. It's essentially a Netflix style browsing, but each one of these sections, very similar to Netflix, is driven by its own ranking function, right? All very similar, all following those 1 through 4 steps that we talked about at the beginning of the talk, but each one's different and aimed at a different segment of the population. The architecture diagram stays pretty much the exact same. We just have a couple new merge scores stored in the SQL DB, right? Maybe these are the remixes, right? And in that case, we wouldn't actually have to upload any new Painlesses. If you do want to craft some new Painless, lots of these do have new Painless components. You do need someone with a little bit of Elastic Dev experience to do that. But still, at the end of the day, you have the tools there where other people in the org, BI folks, can actually monitor and alter those weights, right? Really important if people are running optimization tests around figuring out which weights are the best weights to use. So we do this, we release Curations, which is not as big of a lift as we saw before, but still a significant lift in terms of the bottom line, right? 1% lift on e-commerce shop, everyone would take that. And the reason here was that those personas were already kind of well targeted and well defined, right? We're just making it real time. So not as big of an impact in the Curations as it was on the freeform search results, but still a win nonetheless, right? And we always, who doesn't like a little win every now and then? This is the one little gotcha of doing a bunch of Painless scripting. Painless takes a lot of CPU, right? This is one of, what are you going to do? Anything that's going to do a bunch of compute takes a bunch of CPU. So this is what it looked like when we rolled out all of those curations to prod, right? We were okay when we just had the one merch score running for the baseline search. But as soon as we released that fleet of 9 curations or 6 or 7 curations out into production, it will, our CPU started blowing up, our cluster started having a bad time, essentially. And this is what we ended up doing to fix that, right? I already told you so far at this point, we have about a 4% lift over the bottom line where we started. We ended up moving up a couple tiers in terms of elastic compute, moving over to a CPU optimized instance, all super easy, drop down kind of click of a button thing, wait 5 minutes for the instances to spin up and boom, re-index and we're off. A small increase in the bottom line. I remember being a little nervous about this when we presented it to the C-suite, and they were not worried about it at all because it's very, very small price to pay relative to those other increases. So this is one of the trivia questions. Actually, this is the upgrade slide that I wanted to show you guys. So this is kind of where we were, right? We went from here to here, and then this is that helped us drop CPU down to something measurable. But this was another big thing that we wanted to have in the system too. We started to look for other ways we could reduce the CPU. And if anyone has an idea what these two graphs have in common, or these two pictures rather, CPU usage plummeting right here at midnight, and then this buoy right here. If you guys can get to chat and throw answers in, that's cool. Philip, I will try and get your questions. I was foolishly in the private chat wondering why no one was saying anything, so I'll answer those there at the end. But if anyone has an idea what these two things have in common, I'd love to hear. I'm just gonna do because the next slide gives it away. That's the unfortunate part of giving slide-based talks. But anyway, so the thing that these things have in common is they're actually they're sitting somewhere in this map. If anyone's done any geolocation services, I'm sure you felt this pain before. What happens when you encode something that you don't have location data for? Someone has a browser feature turned off, etc. You end up looking for this place at 0 latitude and 0 longitude. It's what's known jokingly as Null Island. That was a picture of the buoy. It's a scientific research buoy that sits out there all the time. And just turning that feature off really resulted in that CPU drop too. So we bumped up CPU. We found this Null Island bug that we were kind of inflicting onto ourselves, and turned that off. And we're actually to scale back down a little bit on the Elastic Cloud cluster. We still use the CPU instance, obviously, because we have a very small index, right? We're not strapped in terms of disk space or memory space or anything like that, but we want all of these real-time computations happening. So we want that CPU. So we're gonna still stay on the CPU instance, optimized instance rather. But okay, so personalization is kind of the third thing here. And then I'll wrap up hopefully with a couple minutes for questions. But like I said, all of that user research that went in, we know that when people are actually browsing certain, we call them tiers or kind of levels of brands of tire, they're much more likely to purchase tire in that level. Like if I go to a Goodyear, go look at the Goodyear product page, I'm much more likely to purchase a Goodyear tire later. Maybe not in that session, but down the stream, right? It's an indicator of brand loyalty or an indicator of brand interest. And so wouldn't it be great if we could actually start tapping into that with our Painless params as well, right? And this talk is all about flexibility. So yeah, you can totally do that. So this is just a little demo example of a best rated curation without any personalization added to it. And so if you guys aren't tire knowledgeable people, those Kumo tires, they're a tier 2 tire, right? This is tier 1 is the most expensive. That's like your Goodyears and your Pirellis. This isn't on the quiz. I should have had that as one of the trivia questions, but next time. And then it goes all the way down to tier 4. So we left to right, we go Kumo, tier 2. General Tire, that's kind of a bargain brand. That one's a little more expensive, but still a tier 4. Then you have a Pirelli name brand tire, tier 1. Cooper tires, tier 2, and then Hankook, tier 2, right? So if you go to one of these Michelin pages, again, a tier one company, what you get back is you start showing all, these are all tier 1 and all Michelin tires here. So this is actually the brand customization, not the tier customization. But what we do is we start putting more Michelin tires in front of people that we know are interested in Michelin tires, right? This is part of the thing that we're trying to balance personalization with business interests as well, right? So this is really nice, and it puts things in front of people that they're more likely to purchase, which is exactly what we're after as an e-commerce search team. If you visit the Arturo brand instead, or go to there because of an ad, this could come through email, whatever, you end up getting a different spin on the Arturo stuff. So not only do you don't have any Arturo tires coming back here, but you have tires in the same tier as Arturo. So these are kind of competitors, right? These are tier 3, 4, 3, 3, 3 in terms of reading left to right. So you're putting similar tires in front of people, and all kind of powered by Painless in the back end, right? So this is just kind of the summary of what happens when you go from no personalization all the way here on the left column to a tier 1 Michelin personalization, right? You still get tier 2s. We're not excluding those. You just have to look a little bit deeper to find them now. And then finally on that tier 3, right? You have a bunch of tier 3s and tier 2s coming in. And just to be clear, this isn't a pure sort, right? We're adding a component to that merge score that rewards the like tier tires so they float to the top. We don't want to do anything as heavy-handed as just sorting, right? We could have done that without doing any extra clauses, but the point is this nice blend is really what you're after when you come to this kind of strategy, and it works really well, right? So finally we get to the most lift. When we did this curations, we got a 5% lift on these conversions with personalization, which was huge, kind of exceeded. We figured we were trending towards the asymptote, right? We had seen 3, 1, we were kind of thinking we were going to get about 1%, and we were super excited to see this. So needless to say, no one's worried about the 15% bump I put on the Elastic bill anymore. And everyone's just super proud of all the work that went in. But it's not just an Elastic effort, it's really the entire org. So you can't do any of this without great user research. But once you have that, you can definitely implement something like this for your e-commerce shop. So Like I said at the beginning, SimpleTire is actively hiring for a search architect. So if you like working with Elastic, they use a PHP API. Not that that's a deal breaker, or maybe if you love that, please, please, please either reach out to me or reach out to Mark Pereira, and we'd love to talk to you. So